Hey, welcome to the Explainer. Today, we're diving into a piece of technology you've almost certainly used, probably dozens of times just this week, without even realizing it. It's called Apache Kafka. This thing is basically the hidden engine behind so much of the real-time internet, so let's pull back the curtain and see how it all works. All right, to really get a feel for Kafka, let's set a scene. Imagine we're running a website that gives you live, real-time stats for the biggest soccer match on the planet. You know, every single goal, every substitution, every yellow card. It all has to pop up on our site the second it happens. Now, for just one game, our setup is super simple, and hey, it works great. An event happens on the field, a server that we'll call a producer fires that event onto a message queue. Then another server, our consumer, grabs that event and immediately updates the website. Easy, right? Perfect.
But, what happens when you get really popular? What happens when our simple little system has to handle not just one game, but hundreds, maybe even thousands, all playing at the same time?
So, let's just imagine FIFA goes completely nuts and expands the World Cup to 1,000 teams, all playing at once. Whoa! All of a sudden, our single little queue is totally overwhelmed. It's like trying to drink from a fire hose. So we think, okay, let's just add more servers. But that creates a brand new, massive problem. How on earth do you keep all the events for one specific game in the right order? And this is the chaos that you get. When you're just randomly throwing events at servers, a substitution that happened in the 83rd minute might actually get processed before a goal that was scored in the 80th. And suddenly your real-time stats are just plain wrong, and your website is a total unreliable mess. Not good.
Okay, so to fix this huge problem of scale and this really crucial issue of ordering events correctly, we need a much smarter system. And this is exactly the kind of problem that Apache Kafka was born to solve. So the first big idea Kafka brings to the table is something called a topic. The easiest way to think about a topic is as a dedicated feed, or a category for a specific kind of event. So we could have our soccer stats topic and a totally separate basketball stats topic. It just keeps all our different data streams nice and organized. But okay, one feed isn't enough for that fire hose of data, right? So a topic gets broken down into one or more partitions. Now you can think of a partition as just an ordered log file. New events just get slapped onto the end. And this is important. They are unchangeable. This right here is the absolute key to scaling because you can spread these partitions across a whole bunch of different servers. So let's just nail this down because it's super important. A topic is the logical idea. It's the what. It's how we organize our data. Partitions are the physical reality. They're the how. It's how we actually scale all that data across our system. All right, so how do we actually fix that out-of-order mess we had earlier? We do it with a partition key. When our producer sends an event, it attaches a key. For us, that would be the game ID, something like Brazil vs Argentina. And Kafka is smart. It uses that key to make absolutely sure that all the events for Brazil vs Argentina land in the exact same partition every single time. Problem solved. Order is guaranteed for that game. Okay, but what about our poor consumer trying to drink from that fire hose? We solve that with something called a consumer group. Now we can spin up a bunch of consumer servers and they all work together as a team. Kafka is clever enough to automatically split the partitions between them, and it guarantees that any single event is only ever processed by one consumer in that group. This means no more duplicate work, just clean, efficient, scalable processing. Awesome. Okay, so we've got the main players on the board: topics, partitions, and keys. Now let's actually follow a single message all the way through the system and see how it all clicks together.
Now, this is where the magic really happens. The whole journey is super efficient and totally predictable. Our producer sends a message with our game ID key. Kafka takes that key, runs it through a hash function, and that calculation tells it exactly which partition to send it to. The message gets written to the end of that partition's log file, and it's given a unique sequential number called an offset. You can think of this offset as a bookmark. It's brilliant, really. Consumers use that bookmark to keep track of exactly where they are. So if a consumer crashes and has to restart, it knows precisely where to pick back up without ever missing a single event. So that whole World Cup website thing, it's not just some random analogy. These exact problems of scale, of ordering, and of separating different parts of a system, they are precisely why Kafka has become such a fundamental piece of the internet for so many huge companies.
Well, hello there. I'm Gemini. That battery can last up to 24 hours even with the always-on display turned on. It's pretty cool. So, what's that number? 80%? That's the percentage of Fortune 100 companies that rely on Kafka. This isn't some niche boutique tool. We're talking about a core piece of modern data infrastructure, handling trillions with a T of events every single day.
And you see these use cases everywhere, literally. You upload a video to YouTube? Yep, Kafka's probably kicking off a message to transcode it into all those different qualities. Ever been stuck in one of those virtual waiting rooms for concert tickets? That's almost certainly Kafka in the background, making sure the line is fair and processed in order. It's the engine behind real-time ad click streams and broadcasting live video comments to thousands and thousands of people at the same time.
Okay, if there is one thing you walk away with today, it has to be this. Kafka's real superpower is that it decouples your systems. It creates this massive, durable, reliable buffer that sits between the services creating data and the services that need to use it. This means your producers and consumers can be scaled up or down, they can be updated, they can even fail, completely independently of each other. And let me tell you, that freedom, it is an absolute game changer in software architecture.
And all of this leads to a pretty mind-bending final thought. We're moving into a world where basically everything is an event. Every click, every order, every sensor update, it's all just a constant stream of data that needs to be processed in real time. So, as we look to the future, the real question isn't what's built on streaming, it's what won't be. Thanks for joining me for this explainer.